Today we're going to be talking about congruent triangles. And going off of congruent triangles are similar triangles, which we've already learned about. So in the past, we've talked about how triangles that are similar are proportional, which is another way to think of it. And they have the same angle. So they're proportional sides with equal angles. And that's what makes triangles similar. And so if we look at these triangles below, are they similar or not? So if we look at the two on the left-hand side, we have 4 over 8, 4 to 8, which is just 1/2. So now if we look at the other two sides, 8 over 16, oh, well, that's also 1/2. And same with 12 over 24 is 1/2. So are these two similar? Yes. And they're similar because our angles are equal. Notice they're set up the same way. And our sides are proportional. Looking at our other two triangles, are these similar? Why or why not? So let's see if they're proportional. 5 and 8. 5 over 8. Okay, that's simplified. Next sides are 5 over 6. These are not equal proportions, and also we know they're not similar because right here we have a right angle, and in this triangle, none of our angles are right angles. So are these proportional? No, and it's similar, and they're not similar because they don't have proportional sides, and their angles are not equal. So this is a review helping for what congruent triangles are like. So, going back to the first page again. When triangles are similar, notice similar, which we already know, angles are equal, and sides are proportional. And now we're going to move into congruent. So remember this for similar, and let's see what congruent means. So first I just want to ask, what does it mean for things to be congruent? And so you might have a different idea or image in your mind, but when I hear things are congruent, I kind of think of next to each other. Congruent, maybe same. And that's pretty much what it is. Congruent triangles are essentially the exact same triangles, just laid out differently. And when we're denoting congruent in a symbol form, it's an equal sign with a squiggle over the top. And that's just good to know for the future when you get more into geometry. So, when analyzing triangles that are congruent, notice we're no longer doing similar. We have these two triangles right here. We have our green one and a yellow one. And when looking at these congruent triangles, notice that all our angles are equal, like similar triangles, but now notice also our sides are equal. Just like, which is the new part. That's not like similar triangles. So this is like similar ones, and then this is what makes them congruent. Not only are angles equal, but our sides are equal. And so if we look at these two triangles above, in this green one, here's our obtuse angle. Here's the correlating obtuse angle. Then our next angle, and our skinniest angle down at the bottom is right there. All I did was I took the green triangle and I rotated it just a little in just an arc to try to make my angles move. But I didn't change anything about the triangle. And so they're congruent. They're exactly the same. Sides are equal and angles are equal. And that's all congruent triangles are. So the most important things to know about congruent triangles is that the only way they can be different is by how they're moved. And you can move them using either a turn a flip, or a slide. And turn, flip, and slide are the 3 basic vocabulary words. And next year you'll get more in depth with these, but a turn is also called a rotation. Notice we take a triangle and we rotate it however we want, but we don't do anything besides rotating it. And that's what I did in the last slide. With a flip, that's a reflection. And so notice here, they flipped it over our y-axis. So they took the y-axis and they did a mirror image over that. And then a slide is called a translation. And what you do is you take your initial triangle and you move all 3 points the same distance. And then you just form a new triangle between those points. So you either turned it as a rotation, you flipped it over an axis as a reflection, or you slid it as a translation. And just know that that's how congruent triangles can move. They can either move using a turn, a flip, or a slide. But they don't actually change shape. So, if we were going to make or construct and label 2 triangles that are congruent, you can do this any way you'd like. So, I'm going to make a 90-degree triangle just because then I know it's 90 degrees. And I'm going to say we have 3 inches, 4 inches, and 5 inches. And that's a perfect right triangle, so I know that actually will work out. And we'll say that this is 60 degrees and 30 degrees. And I'm just guessing on those. It doesn't have to be exact, and because it is in your notes and it's harder to do that on paper. But if we were going to make a congruent triangle to the one I have right here, remember we can either do a turn, a flip, or a slide to it. Or you can do a combination of any of them. So I'm going to maybe flip and turn, or if you just turn it, it kind of works too. But I could flip it so it would look like this. Now my right triangle would be here. I'd have 60 degrees here, 30, 5 inches, 4 inches, and 3. I could maybe do a rotation or turn where it's like this now. And we would turn the 30 degrees to here, 60 to here, 5 inches, 4 inches on top, and 3 inches on the side. And so my green one was a flip, and the purple triangle was a turn. You could also do a slide, but because it's not on a graph, it's a little harder to see. But it doesn't really matter. All we need to determine is that when you label, construct, and label, don't forget the label portion, triangles that are congruent, all angles and all sides are the same in both triangles. And that's really what you need to take away from today. Congruent triangles have the same angles and the same sides as one another.